Now we are moving to next part of this chapter. Now we have to deal with refraction. So students, have you ever wondered why you see twinkling stars at night? Some stars, okay, you must be knowing what is the difference between star and a planet. If you look it from your naked eye in the sky, planets do not twinkle whereas stars twinkle. So what is the basic difference? Moreover, why do stars even twinkle? Second thing, when you place a pencil inside a tumbler filled with water, it will appear to be bent from the point which is inside the water, right? Not just that, if liquids of different densities are taken, the refraction or the bending appears completely opposite. In that case, refraction is occurring or the bending is occurring in certain direction, whereas in this case, due to the different in density of the liquid, it is appearing in some other way. So what is the phenomena we are studying right now? Refraction. Refraction is the phenomena of bending of light. The main thing is, this is bending of light from where? From its path. When, now this is from where? Okay, from its path. When, this is where and this is when. When does this happen? When light travels from one medium to another. Now this thing doesn't specify if the light is traveling from rarer to denser or denser to rarer medium. It just states that refraction will happen, that is the bending of light will definitely happen when the light is traveling from one medium to another. So how, okay, before we explain refraction, let's study the cause of refraction. Okay, what do you think the cause of refraction would be? I'll explain you the exact reason what is this refraction about and what is the basic cause behind it, but you don't have to study that much in detail because this is not in your syllabus. I am giving you some extra topics to know that. First of all, light has two types of natures. One is particle nature and another one is wave nature. So light has dual nature, particle as well as wave nature, right? According to particle nature of light, light travels and behaves as particle when it interacts with different material or different bodies. For example, this is a denser medium, consider a glass slab. Here light rays are incident. Okay, we are talking about ray number 1 and ray number 3. Alright, first of all, ray number 1 and ray number 3. Ray number 1 do not experience any kind of denser medium on its way. So ray number 1 is going straight up to its destination, whereas ray number 3 is now experience a denser medium which is a glass slab. Okay. Now according to particle nature, suppose if I run from this point to the camera, what will happen? I'll have some speed, but this same space is now filled with water up to this level and I'm running again. This time my speed will be slow. Why? Because I will be facing a lot of resistance due to this denser medium. Similarly, this particle of light or the particles which you know as photons, these particles due to obstruction given by the denser medium will slow down in their speed. Done? So one thing we know, that speed is a deciding factor. Speed of light, and speed of light is slower in denser medium. In your books up to class 10th, the reason which we give for refraction is refraction occurs to the fact that light has different velocities in different medium. Denser the medium, lesser will be the velocity. That is the basic cause of refraction. This much answer is definitely done for your boards. I am giving you the exact answer. You don't have to remember it or learn it. I am giving you the exact reason why, what is happening. According to particle nature, this ray got slower down, right? But according to wave nature, light travels in the form of wavefront. Now to understand what is wavefront, consider a pool of water and here I am dropping pebbles. What will this give? It will give me ripples, right? Suppose the pool of water I am dropping pebbles, it will create ripples. All of this ripple will expand at a similar pace or at a constant velocity. That means this whole wavefront will form at once, right? It will keep going on bigger and bigger until and unless it gets diminished or diffused by the present medium, or the energy gets completely dissipated by the secondary medium. Now, when this wavefront is expanding, you can see that this wavefront and all the particles on the wavefront has a constant velocity. That means, suppose this is the pool of water, I am dropping the pebble here, the crust and trough formation, all the particles which are on crust rises above at the same time, and all the particles which are on trough goes down at the same time. This doesn't happen that half of the particles go upwards before then to the rest half of the particles. That means a wavefront has a constant velocity. Similarly, this light rays are actually part of wavefront, and because wavefront has a constant velocity, this wavefront will reach this part at the same time. Now come back to ray number 1 and ray number 3, that this ray and this ray has to reach here or the destination at the same point, but now the speed of this ray has been decreased. Alright, due to decrease in the speed, something must be done to compensate the time lag. What can be done? What is the shortest distance between two parallel lines? The straight line or the perpendicular. That is why rays bend towards the normal when light ray travel from rarer to denser medium. So instead of going straight, because that would have resulted in more time lag, right? Because speed is slower up till here and speed is back when the ray is out of the denser medium. So just to cover the time lag, ray covers a smaller distance. That is why rays bend towards the normal when ray travels from rarer to denser medium. And when ray travels back from denser to rarer medium, now the time lagging is not required. Now they will travel with the same speed, and hence all these rays will reach here, or this wavefront will reach this wavefront at the same time. So this is the basic reason why refraction even happens. Refraction, the basic cause is due to simultaneous effect of both particle as well as wave nature. But if up to 10th level, if you say that light refraction happens due to difference in speed of light in different medium, then that definition is absolutely right. So let's move forward. This is a glass slab and a ray diagram for what is happening. As I told you, what was the laws of reflection? Laws of reflection was I was equal to R, and we are talking about reflection, not refraction right now. And what? The incident ray, normal and reflected ray, they were lying on the same plane, right? Similarly, there are laws of refraction on basis of which refraction is governed, this whole phenomena. The first law in the law of refraction is that the incident ray, normal ray and the refracted ray, they lie in the same plane. And second is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. These are the laws of refraction on the basis of which we have drawn this ray diagram. So generally, when refraction happens, ray, you have to remember this, bends towards or away from the normal. So when does the ray bend towards the normal? When it is traveling from rarer medium to denser medium. And when does it bend away? When it is traveling from denser to rarer medium. This is the case scenario. So now you can see here that at this point, this light ray is going from a rarer or the normal air to glass, that is rarer to denser medium. So instead of following straight line, it bends towards the normal. So this is the angle of incidence which the incident ray makes with the normal, and it is the angle of refraction which refracted ray makes with the normal, right? On this surface, here there is another refraction happening. This time ray is going from denser to rarer medium. So this time, instead of going straight like that, ray bent away from the normal, and that is why this is another refraction. So if I am talking about this surface, the angle of incidence would be this angle, whereas angle of refraction would be this angle. The point to be noted is angle of incidence and angle of emergence, they are always equal. Okay, this is a rectangular glass slab experiment. This can be actually seen or measured by using glass slab and laser light. you have those red color laser light in market, you can take a glass slab, you can draw, or you can just point laser light at any angle, at measurable angle. Suppose you have already marked 50-degree line, and then you make the laser go through 50-degree line, and then you can see that the light ray won't be following a straight path. Instead, it will change its path quite a times. Actually, whenever it will, not quite a times, it will, ray will bend every time it is changing its medium, either from rarer to denser or from denser to rarer. This is a more technical kind of diagram where I have shown you, this is the incident ray, normal, this is angle of incidence, incident ray, and this outside is air. Now, ray, instead of going straight, suppose this glass slab is not present, then this would have been, the dotted line would have been the actual path of light. But due to the presence of denser medium, the ray got bent towards the normal. Now you know how, what is towards. This is angle of refraction now, and here again at this surface, now it is traveling from denser to rarer medium, it got bent away from the normal. So this ray and this ray, they are always parallel. That means the actual path of light and emergent path of light will be always parallel. So what just happened, the ray just got shifted by some distance, but it is following the same path or the same direction. So this distance is called lateral shift or lateral displacement. Alright, now the next point, this ray diagram shows you two things. Number one, as we have discussed that angle of incidence and angle of refraction has a common ratio stuff, that is given by Snell's law, which we are going to talk about. But for now we know that if angle of incidence is there, there will be angle of refraction as the ray is traveling from rarer to denser. But just in case if the ray is traveling straight towards normal, that is angle of incidence is 0, then angle of refraction will also be 0 and there will not be any refraction. Or you can say this thing actually can be explained in two ways. If I am saying that whenever light changes its medium, light gets refracted according to the given laws of refraction, right? And now I am contradicting my statement that if the light ray is going along the normal, then there is no refraction. Actually, refraction is there, but refraction is not visible because the ray is refracting in its own plane. Either it will be coming out of the paper or it will be going inside. That means the kind of refraction happening won't be visible to you. That is why some books just write that there is no refraction when light is traveling straight towards normal, whereas a visible refraction is in this case when there is a proper angle between normal and the incident ray, then angle I will have an angle R, right? Okay. Now this is called refractive index. This was given by Snell's law. The laws of refraction stated that this ratio of sine of angle of incidence to the sine of angle of refraction is a constant, but it did not give us the name of that constant. Snell later on gave us the constant's name, that is sine I over sine R is called refractive index, which is majorly denoted by mu, but in some books it is denoted by n. So if it is denoted by mu or n, just remember it. This is now that they are talking about refractive index. So refractive index is a governing practical physical aspect which tells us how much refraction is going to happen. That means higher the refractive index, more will be the refraction, and refractive index actually depends on the density of the medium. Suppose we are talking about glass slab and we are talking about diamond. Which of the two is strongest? Diamond is strong because of the density. More the density, stronger will be the material. So if diamond is strong, that means the diamond will have a very high refractive index and hence a very large refraction will happen in case of diamonds, whereas glass slab will have less refractive index pertaining to the different values of pertaining to less value of density, and that is why okay, that is a separate point. Now sine I upon sine R, that is the Snell's law, that's ratio of sine of angle of incidence to the sine of angle of refraction is called refractive index of the material. Though at the very beginning I told you that refraction occurs due to the basic property of light, that is speed. Speed of light is different in different mediums. Higher the denser the medium, lesser will be the speed. So refractive index is also defined by this formula, that this is the ratio of speed of light in air to the speed of light in that particular medium where light is entering, right? This is the refractive index of a medium. So, two definitions, sin I upon sin R, or the refractive index is denoted by speed of light in air upon speed of light in that particular medium. This is the second formula. Now, till now we have studied what is refraction and what are the laws and formulas associated with it. Now, as we have done reflection from spherical surfaces, this time we are going to do refraction from spherical surfaces. And when we talk about refraction, that means we have the figure, for example, mirror was reflecting body, now we'll have lens as a refracting body. And again, the constituent or the formation of lens is based on the same fact that take a glass slab, this much portion and this much portion, join them up, they will become convex lens, and similarly if they are joined in opposite direction, they will become concave lens. So this is how lenses are formed, convex or concave. So these two sides are basically, the curvature sides are actually part of big spheres from which they are carved out. So that is why they also have that same center or radius of curvature, half of which we will be calling focus or f. So I am removing c and writing it as 2f. Similarly, in this case, the difference will be, in case of convex lens, the first side focus is on this side, whereas in case of concave, first side focus is on the left side. Let's see. These are our two lenses, convex lens and concave lenses, and this is a diagram which clearly shows how lenses are formed. We have taken a spherical surface or spherical glass medium, then out of which we are going to take this much thing. So this part, this depth up to which the lens depth is taken, that is called aperture. Second, the whole center, this complete center of the sphere is center of curvature, which is actually the radius of curvature as well. Half of it is focal length, that means this is f, this is 2f. If we join all these main points from the pole, focus and center of curvature, it will be called principal axis, right? Now, ray diagrams are made on the spherical lenses exactly the same way we made ray diagrams on the spherical mirrors. That is, the same type of rays are considered. I'll draw and I'll tell you. This figure actually shows us why convex lens is called converging, whereas concave lens is called diverging. All the parallel rays, okay, let me talk about the rays first. I'll talk about all those three rays. First ray is, see, one more thing, in case of convex lens, there will be two focuses and two radius of curvature, right, of this surface and this surface, but the measurements and the ray diagram always are to be taken from the first surface only. That means the radius of curvature of the first surface, the sphere will be on this side, that means it will be on this side, f and 2f, right? So I am talking about rays. First one is the ray which is coming parallel to principal axis. It will always pass through the focus. Ray number 1. Ray number 2 is the ray which is passing from optical center will go straight undeviated. This is because the amount of refraction happened on this surface, the reverse refraction happens on the opposite surface, and hence it follows back to its original path. So second ray is the ray which goes from optical center will not change its path, it will go straight. Same is true for concave lenses also. First one, the ray which is parallel to the principal axis will pass through focus. Now I have just told you that the distances to be measured and all those ray diagrams which are to be drawn are taken from the focus and 2f or the focus or curvature from the first surface only. So this first surface, for this C or 2f would be here, and half of that is focal length would be this side. So this ray has to pass from this side, that means it is going to do that virtually. So extending this part, normally this ray will go straight in that side, but it will appear to be coming from focus. So first ray remains same, that is ray which is coming parallel to principal axis will pass through focus.